Hello everyone, welcome to the Module 3, Data Collection and Understanding. So before we start to go through the whole reading material, before we go through the whole content, I wanted to check the reading guide at first to see what I'm expecting from you to learn from this module. After you go through the reading guide, I want you to download the reading material and go through the slides with me. Okay, so we talk about data collection and understanding. So you should still remember this diagram. So the business analytical process. We are currently at the third major step, determining alternative solutions, which include three sub-steps: data collection and understanding, data preparation, and data modeling. This is also called data flow in business analytic project. To better understand the data flow, you need to understand two important concepts: information management and enterprise data governance. Information management refers to the systematic application of information technology tools, methodologies, and best practices to collect, process, consolidate, store, and protect data. It often originating from fragmented or inconsistent sources. The primary object of the information management is to transform the raw data into valuable information that supports effective decision-making across an organization. So this diagram illustrates its core logic of data-driven business analytics, which shows how organizations move from raw data to decision-ready information through a managed technical process. If information management is an umbrella high-level concept introducing the logic of data flow, enterprise data governance is more related to the first step of data flow, which is the data collection and understanding. Enterprise data governance refers to the strategic framework and a set of policies that ensure an organization's data is accurate, consistent, secure, and trustworthy across all departments and systems. For any data-driven initiative, whether it's improving customers' retention, forecasting sales, or optimization operations, the quality of your insights can only be as good as the quality of your data. At the data collection and understanding stage, organizations often face fragmented sources, like customer data in a CRM, sales transactions in an ERP system, and marketing engagement tracked by the third-party tools. Each source might use different formats, naming conventions, or data standards. Without strong governance, these inconsistencies lead to confusion, duplications, and distrust in the data. But when enterprise data governance is in place, it enforces things like standardized data definitions, clear ownership of the dataset, validation rules to catch error early, and process for metadata and documentation. This is crucial in the understanding part of the step, because you're not just collecting raw values, you're collecting meaningful, context-rich information. This governance ensures that when analysis, data science, or business users access the data, they're all speaking the same language and can move forward with confidence in their insight. Thus, enterprise data governance is not just about compliance. It's about building a foundation for trustworthy and scalable decision-making. Now, let's talk about the detailed stages of data collection and understanding. Data collection and understanding marks one of the most essential starting points in any business analytics project. This stage is tightly connected to the principles of information management. Our main goal here is to identify and integrate relevant data sources. These might include CRM systems, ERP platforms, internal sales database, social media streams, or even IoT devices. So why this step is so critical? Because the quality and the structure of data gathered here directly influence the accuracy and the reliability of our analytics result. A strong data collection process ensures that data is relevant, complete, and well organized. It makes future analysis smoother and more meaningful. So the first task is data acquisition. This is about finding and assessing the necessary dataset. We might be working with flat files like CSVs, querying a database, or connecting to APIs from external services. It's also important to make sure we have the correct credentials or permissions. Next, data loading for exploration. Once access is granted, we load the data into our analytical tools, whether that's Excel, Tableau, Python, or SQL. This allows us to begin exploring, understanding how the data is structured, and spotting any obvious issues. Finally, initial data understanding and preparation. At this stage, we look deeper into the data. Are there missing values, duplicate records, inconsistent formats? If we're combining dataset, we may also need to merge or join them to create a unified dataset for analysis. This careful preparation sets the stage for the modeling and the visualization steps that come later, and it significantly reduces errors down the line. Your output should be a structured report, which includes a list of all datasets collected, along with where they're stored, the tools or methods used to collect them, any problem you're faced, such as the access issues, file format mismatch, or incomplete data, and most importantly, how you solve them. So this report not only keeps your project on track, it also supports transparency and helps others replicate your work if needed. Let's walk through a simple example of how a business turns raw data into useful insights. First, the data is collected from multiple sources. This might include customer information, transaction history, and product details. Next, the data go through a transmission process. Errors are cleaned, missing values are checked, and everything is merged and standardized. This makes the data reliable and analyze ready. Then, the clean data is stored into the warehouse, a central storage system optimized for analysis. From there, business users can explore dashboard, scorecard, and report that visualize the trends and the performance metrics. Finally, these insights are compiled into a data understanding report, helping decision makers take smart, data-driven actions. So in summary, the key points in data collection and understanding is good analysis starts with good data, and good data start with proper collection and understanding. So most of the original data we use actually comes from database, as known in the diagram. Unlike Excel or PDF files, which often contain well-organized, finished data, database store data in a more complex and structured way. They're designed for efficiency and score, not readability. That's why, before we can extract the data effectively from these sources, we need to understand the basics of how databases work, what they are, how the data is structured inside them, and how we can interact with them using tools like SQL. So, in the coming section, we will take a step back and explore the fundamentals of database. Database is an organized collection of data stored in a structured way so that we can easily access, update, and manage it. Databases are everywhere. They help store customers' records, track inventory, manage transactions, and more. There are a few key things that make database powerful. First, data is stored in a structured format, which makes it easier to work with. They allow for quick and efficient access to the specific data we need. They maintain data inventory, meaning the information stays accurate and consistent. And finally, they support multiple users, so many people can work with the same data at once. In most real-world systems, databases are managed using something called a database management system, or DBMS. This software helps us to store, update, and retrieve data with ease. To really understand how database work, we need to look at three basic building blocks: the database, the schema, and the table. These form the foundation of most modern relational database, and that's exactly what we will explore next. In traditional database theory, a database contains one or more schemas. A schema is like a folder. It groups related tables, views, and other databases objects together. It helps keep things organized, especially when different users or applications are using the same system. But in MySQL, which is the database system we will use in this course, things are a bit different. In MySQL, the terms schema and the database mean the same thing. So when you create the schema, you're basically just creating a database. And when you create a database, you are actually creating a schema. So all the tables go directly into the specific database. Now let's talk about the relational database, the most common type of the database used today. A relational database stores data in tables, which are also called relations or entities. Each table is made up of rows and columns. The entities are the things you want to store data about, like customers, product, or orders. The columns represent the details or attributes of that entity, like name, price, or date. Each row is a record, a single instance of that entity. For example, if you think about a table for a student, the columns might include name, social security number, phone number, address, age, GPA, etc., etc. Each row is one student with specific values for each of those fields. We normally use entity relationship diagram, which is ERD, to visually represent the structure of a database, showing the relationships between different entities. Let's walk through a specific ERD for an e-commerce ordering system. We start with the customer entity. This represents the individuals or organizations who place orders. Customers are connected to orders through a relationship called mix. This means a single customer can make many orders. That is a classic one-to-many relationship. Next, we have the order entity, which sits at the center of the ERD. Orders are connected to multiple other entities, like each order contains normal product. This forms a many-to-many relationship because one order can include many products, and each product can appear in many orders. Each order is also handled by an employee, someone responsible for processing it. And each order is also shipped by a shipper, like a delivery company. The product entity holds all the items available for sale. Products include additional attributes like category and suppliers. So in this simplified ERD, these are shown as attributes. But in a full database model, they could also be separated entities with their own tables and relationships. So this ERD illustrates how entities, relationships, and attributes work together to model real-world business process within a relational database. While a high-level entity relationship diagram provides a conceptual understanding of the entities and their relationships, it often omits specific attributes and constraints necessary for implementation. To address this, we use a database schema diagram, also known as relational schema, which represents a more detailed and complete representation of the database structure. This type of diagram illustrates each table, the entity, its columns, which is also the attributes, as well as the primary keys and foreign keys that define relationships between tables. Color codes or label legends help distinguish these components. For instance, table names may appear in blue headers, primary key in red, foreign key in purple, and regular attributes in pink. A key is a column or set of columns used to identify, access, and enforce relationships between records in one or more tables. Keys are essential for maintaining data integrity, uniqueness, and consistency within and across tables. Two kinds of keys are important in a relational database. The primary key. The primary key is a unique identifier for each record within an entity. It ensures that every row in the table is distinct. The foreign key is a field in one table that references the primary key of another table.
For example, in the orders table, orders ID is like the primary key, as it uniquely identifies each customer. Customer ID is a foreign key, referencing the customer ID in the customers table. These indicate that each order belongs to a specific customer. The order table records each transaction. The primary key is the order ID. It has three foreign keys: the customer ID, employee ID, and shipper ID, which connected to customers table, employees table, and shipper table. Additional columns include order date. This table connects to multiple others with many-to-one relationships, like one customer or one employee or the shipper can be linked to many orders. The order detail table connects orders and product in a many-to-many relationship. It has foreign keys to both orders and product. The quantity column shows how many units of each product were ordered. Then we have customers, employees, and shippers table that have a connection with the order table. The customer table stores buyer information. Customer ID is the primary key. Other fields include customer names, contact names, address, city, postal code, and country. One customer can place many orders. The employees table contains staff data. Its primary key is employee ID. Additional attributes include last name, first name, birth date, and notes. And each employee may handle multiple orders. The shippers table represents delivery companies. Its primary key is shipper ID. Other fields include shipper name and phone number. Each shipper can deliver many orders. The product table lists items for sale. The product ID is the primary key. Other fields include product name, unit, and price. The foreign keys include category ID for the categories and supply ID connected with the supplies table. One product can appear in many order details, and each product belongs to one category and one supplier. So the supplier's label stores supplier details. Supplier ID is the primary key. Other fields include the supplier name, contact name, address, city, postal code, country, phone number, and each supplier can offer many products. And the categories table classifies products. Category ID is the primary key, and other fields include category name and description. And each category includes many products. So this entity relationship diagram represents a retail order management system. We can easily see who made order at what time with what products, and served by which employee, as well as delivered by which shipper. We can also track the source of the product to manage the inventory system. This is an example of a basic database. The real-world database is more complex than this one, but I do believe it is a good start to welcome you to the world of data science. Now let's take a closer look at the structure of the table in a relational database using customers table as an example. The table, which is also called the entity, represents a group of similar things. For example, the customers table stores information about the customers. And in each column is an attribute like customer ID, customer name, contact name, and address. This describes specific details about each customer. Among them, customer ID is the primary key. It uniquely identified every customer in the table. And then each record is a row or the tuple. The one row might describe a customer. For example, names Alvarez Footer Kit with ID number 1, contact Mariel Anders, and address Albro Street 57. Each record stores a full set of the values, representing one real-world customer. This structure, columns as attribute and rows as record, make a relational database efficient, organized, and easy to use. And in this table, customer ID is defined as the primary key. It uniquely identified each customer in the table. No two customers can have the same customer ID, and each customer must have a known value in this column. There is no foreign key in this table though, so let's see another example. In this order table, several columns are foreign keys: customer ID, employee ID, and shipper ID. Each one links to another table, like customer ID connects to the customer table, employee ID connects to the employee table, and the shipper ID connects to the shipper table. These links create relationships between tables and help enforce referential integrity. For example, you can't place an order for a customer who doesn't exist, or assign it to an employee or shippers that isn't in the system. Foreign keys also enable us to pull rich, connected table. With a simple join, we can see not just the order, but also the customer name, the employee's contact info, and the shipper's company. So that's the power of a relational database: clear structure, valid relationships, and meaningful insight. But some people might ask, why not just use one big table for everything? Let's look at an example. If you store the full customer information, like names and address and everything else, inside every order, and that the customers place 10 orders, their information gets saved 10 times. That's repetition, waste space, and inefficient. What if the customer changed their name? You have to update it in all 10 records, and if you miss one, your data becomes inconsistent. So we can use a foreign key, like this customer ID, to store the customer's full information only once in the customer table. The older table just references the customer with a simple ID, eliminating duplication. This approach avoids repetition and ensures updates are made in one place. This structure is called database normalization. It breaks data into multiple related tables, and each focused on one single entity, like customers, orders, employees, or others. The benefit includes less redundancy, fewer errors when updating, better organization, and stronger data consistency. Tables are linked using primary key and foreign keys to form a clean, connected system. That is why relational databases aren't just one big table. They are smartly divided for clarity and reliability. So the next step is to learn how to retrieve useful information from them. This is where the SQL, our structured query language, comes in. SQL is the language we use to talk to a database. It allows us to query data, insert new records, updating existing ones, and then even delete the data. So whether you want to extract data from a single table or join multiple tables for more complex analysis, SQL is the essential tool to get the job done. So to strengthen your understanding of SQL and relational databases, several high-quality resources are available. The most accessible is the W3 School SQL tutorial, which offers clear explanation and interactive exercise for beginners. For more structured learning, Code Academy provides a guided SQL source, though it requires a paid subscription. So if you prefer academic content, Stanford University offers a free course titled Database, Relational Database, and SQL, which covers both theory and practice in depth. And finally, for those who are preparing for technical interviews, LeetCode SQL is highly recommended. It offers a wide range of SQL problems that help sharpen your query writing skills and test your understanding of real-world database challenges. And in this class, we will mainly use the guidance from the W3 School. So now let's take a look at how we interact with database using 3 different types of the SQL language. We can using this simple student table as an example. First of all, we have the DDL, which is called Data Definition Language. This type of the SQL is used to create and modify the structure of the database. Then we have DML, which is called Data Manipulation Language. This led us to add, update, or delete records in the table. And then we have DQL, which is Data Query Language. This is all about retrieving information from the table. So this helps us find specific information from the table, like the student's SSN. So together, these languages let us build the structure of the database, add and change its data, and find exactly what we're looking for. Understanding these categories help you use SQL more effectively and with more confidence. So let's talk about the data definition language at first. So to create a new database in the SQL, you need to use the create database statement. A schema is a collection of database objects, including tables, views, and procedures. So the next step is to create a schema, and then you will use the created schema statement. However, since we are using the MySQL, in which the database equals to sigma, so we only need to create the database without creating a schema. So from now, we're going to actually write in the queries in the MySQL. So I assume you have downloaded and installed MySQL already. If you haven't downloaded MySQL, please go to the syllabus, and here showing you how to, like right here, please install the MySQL at first. So now, before we create the database, I would like you to open the MySQL at first, and then open the this one assignment practice at the same time. So we have module 3 assignment practice. And when you open this one, you will see a couple of the questions I listed right here. So we were using this as the practice and an example to show you how to write the SQL and how different category of the SQL queries works. Okay, and now you will double click this one, which is the local instance. So this is the local local MySQL server you just installed. So you were using your own laptop or PC as a server so that all of the tables of database as you created stored in this server. So you don't need to create all the tables again and again. Okay, so when you create the local instance, you will see something like this. Okay, so this is the interface of the MySQL workbench. And you will see the schemas or the databases on the left side. So to show this, the automatic watch will be administration. So you can actually click the schema and then to see all the databases. All right, so right now we will following
Create a
this
database.
to create it, following these tasks to create a database and then create tables and then to see how to retrieve the table. Okay, so now we go to see the first one, which is to create a database. So we will create a database. Since in the MySQL, database equals to schema, so we don't need to create a schema, or we only need to create the database. And so the first task to create the database called lead business. So we can copy this one and then into the query of the MySQL workbench. So right now you will see that this showing a wrong sign. So this sign means there's something wrong with this query. And because we are actually copy paste a comment, this is not a real query, right? Query database called libs is not a real query. So this is like I want to copy the question or copy the task into the query. So it's not just into the MySQL. So it's not a query want to execute it. This is a comment. It's more like a comment. I will, remind myself what I'm doing now. So we can use dash dash space. So dash dash space makes it's this function, this line. So which means it's just a comment to tell me what this step is doing. So this one it runs nothing. All right. So make sure that this is dysfunctional. And so I want to create a database called this lead business. So what should I do? I will use this query called created database lead business, right? So I'll type in like created database lead business, and then don't forget about semicolon. And you will see something, a blue dot right here. So this actually means this query is functional and you haven't executed it yet. So we just write this query, haven't executed, we haven't run it. So if you want to run this query, what we'll do is we will highlight the query that we want to execute and then click this button. See, it said execute the selected portion of the scripts or everything, right? So if execute the selected portion. So we will click this one, and then you will see something right here that said the action means created database lead business. It is success, right? So this is a green success sign. So now we have a database created called lead business. But it doesn't showing right here, right on the left side, right? Because we need to refresh database list. So to refresh it, we're gonna go to right here to see this little button, the refresh button. We're gonna click this refresh button, and then you will see a brand new database called lead business. And if we open it, we will see there's nothing here because we haven't created any tables, any views, or any store procedures or functions. Okay, so there's nothing there. All right, so we just created a database called the lead business. And then the next steps I wish you to remember is now, since I created the database, but it doesn't mean I'm actually in this database right now, because like you can see, there are 3 different database I have. 4 different database I have: Benyu, lead business, post system, and then the system, right? So if I want to make sure I'm actually using this database, what I can do is I can either double click the lead business. I double click this one. So after I double click, you will see that this lead business, right? This name right here, it is bold. And that means we are actually using this database right now. And if you're not sure whether we're using this one, there's another way we can do is we can write another query called use lead business. Okay, if we write a query like use lead business, and it's success, which means right now we are in the lead business database right now. So whatever we did, whatever we're gonna do, it's all happened inside of this lead business database. So this one is very important if you want to make sure all of the tables, because sometimes we have tables in different database, we have tables in other database, in the same database. So if we are doing some the queries, additions, updating of the table, if we didn't identify the database at first, you might update the wrong tables in a different database. So make sure that every time when you run a query, or every time when you start a query section, using this query to push yourself to successfully locate yourself into this lead business database. Okay. Next step. All right. So this is the how we're gonna create the database. And then after we create the database, we will have we want to create a table, right? So here is, we will create a table called IS335. So table holds the actual data into the database. So to create a table, we will use the create a table statement. And we have to define the columns, data types, and any constraints. So this is the basic example. And you can tell in this example, we have a lead business, which is the database name, and IS335, which means this is the table name. So that actually means we will create the table called IS335 inside of this lead business database. All right. And then this database include several columns, each with its own data type and constraints. For example, the first column, the ID, is of type int, which stores integer values. So the int is the data type. So when we create the table, we have to define the data type for each column. In SQL, there are 3 main data types, which is shown in the reading materials, including the string, like the varchar char, and the number inside of the bracket is the size. The other type is numeric data, like int, float, decimal, or boolean. There's also datetime data types. And you can see all the data types in the reading material. All right, so let's see how to create this. So we're gonna copy this comment right here. This is to create the table called IS335. So we will actually, at first, we'll write the query like created table, which is in lead business database, and we're gonna call it IS335. Okay, and then we will use the bracket. So this bracket means we will define the columns. inside of this IS335. So the first column is ID as we just described, right? So it'll be ID, data type is int, and this is a primary key. Okay, and comma. Now, next one, right here. The next one is the name. The name uses varchar data type, so allowing variable length characters, string up to 50 categories. And it has a not known constraint, so that means a value must always be provided. This column cannot be left empty. Okay, so we will add the name and as the column name, and varchar as the data type with 50 as the maximum length, and with not known as the constraint. Okay. And the next one, the third column is the age, is also an integer, right? So we'll have age int as the data type, and it also asks default value as 25. So that means if there's no age is specified when inserting a new row, the value of the age will automatically be set to 25. So the default constraint is used for automatically assign standard values when no input is provided. Okay, so normally we don't want this to be a known value, but sometimes there's empty values when insert into this table. So we won't have it default value, so to make sure that even there's no data or no value provided, this column will still have a default value, which is 25. And then the fourth column is called email. So the email uses the varchar 100. That actually means this is a string data type, and then the maximum length of this email column will be 100. So we cannot provide any value that are more than 100 characters. Okay, and then this is the constraint with unique. So the unique issue ensures that no two rows can contain the same email address. So there's a little bit difference between the primary key and the unique. Okay, so the primary key can only be applied once per table, right here. So primary key is unique too. There will be no duplicate, no same ID for this table. But the problem is that the difference is the primary key can only be applied once per table, but the multiple unique is allowed. For example, I can have the unique email, I can have unique name, but this that doesn't make sense. We can have like unique age. So the multiple unique constraints are allowed in the same table. All right. So the both constraints enforce uniqueness, but the primary key also implies non-known automatically. So this is the email we have right here. And then the next column is called registration date. Registration date. So based on the name of this column, we know it's a kind of date time, right? So we can have a timestamp as the data type. And the timestamp stores both date and time values with a high precision. And this is also the constraint of this column is default current timestamp. So that means if there's no value provided for the registration date, then the system will using the current time as the value and then insert it into the table, right? So this is the MySQL is very smart. So it will automatically set the column to the current date and time when the new row is inserted, but when this registration date value is empty. And then we have the last column is called active. Okay, active, and it's a type of Boolean and has a default true constraint. So that means the active column will be either true or false. And the default as true means the new record will default to the active unless there's a false specified. All right. So this is how we're gonna create the table, and it's not done yet. Okay. So we have you have to. There's something I want to take a notice right here. So first of all, we have when we create a table, we have a database name and then a table name. Okay, so which means we will create this table IS335 inside of the lead business database. And then when we defined each columns, you will see that since the column is not done, we were using a comma right here to make sure that I tell the SQL, this is the first column, this is the second column. Okay, right? So this is the comma that we have to use when creating the table. But at the last one, when we finish the definition of the active, there's no comma, which means we've done the column definition already. So we don't need the comma anymore after the last column. But since we finish the whole queries for the create database, which means this is a section we just used to create the table, right? So which means this is the section we've done for this query. So you have to have a semicolon to tell the schema, to tell the MySQL, like this is just a subset or a portion of the query. This is required when you finish a section of the query. And now you can tell there is no red arrow sign. So which means so far syntax of the query is correct so far. So we can have a try to create this table by highlight the query, and then we're gonna execute the query. And then you will see that here, the query we just highlighted is executed successfully. And if we go to refresh the data list, then you will see there is a tiny arrow right here showing us there's something more for the tables. So when we click this one, we open the table list, we will see a new table called IS335 is actually being created. And then if we click the columns, we will see all the columns right here. Okay, and then if you click these column names, then you can see that this is the constraints of this ID and constraints of the name, and then constraint of the age, right? So you can see the constraints or the definitions of each columns in each table. All right, so this is how we create a table. Okay, so in addition to create tables, we can also use alter table statement to change the structure of the existing table without deleting or recreating it. As your data needs change, the data structure might need to evolve too. So the alter statement helps you to keep your database flexible and up to date. For example, if you want to rename a column from registration date to registration date in a table you can use the following statement to rename it. But here's one thing. We have to use the backticks around the names because there's a space between the name. All right, so let me show you. So right here, we want to rename the registration date right here, right? So what we'll do is we will see alter table the business IS335 and alter which one? We were using the rename column, registration date, and 2, registration date. So I'm gonna show you without the backtick. So when there's no backtick, you can tell that here is an arrow sign said something wrong with here. And if you put hover a mouse here, you will see that the date is not valid at this position. Okay. So there's error sign, and even we executed this query, we will see error sign right here to say this is unsuccessfully created, and then the arrow code. So which means there's an error in the syntax. So that require us to add the backtick to cover this column name, okay? Because there's a space between. So when there's space between, we have to use the backtick to cover this new column name. And then you will see that with the backtick, there is no arrow sign anymore. And then when we highlight this query and then execute it, this is success. All right. And then we're gonna refresh our database list again. And we open the columns of IS335, and you can see that right here, the registration date is changed. So there's no underscore anymore. There's a space between. Okay, so this is how we're using the alter table statement to change the column. And then we can change it back. So let's do it again. We're using alter table, the business, IS335, and I'm going to change back, right? I'm going to rename column. I'm going to copy this one back to registration date. Okay, so I'm going to change it back, and I execute it and refresh, and then you will see that the underscore is coming back. All right, so this is how we're using alter table to rename the column. And we can also use the alter table to drop the column, add the column, and modify the constraint or the data type of the column, right? So let's see, we want to drop the column age, and then we want to add them back, okay? So when you're using the alter table statement to drop a column, you don't need to specify the data type or the restriction of that specific column, because no matter what, we're gonna delete it, right? So we don't need anything else. We just need to tell the SQL that this is the column name we want to drop it. So execute, and then so here is a successful sign, and then we refresh, and you will see that the age is gone. The age column is gone. Okay, and now it said, oh, I should not drop it, so I want to add it back. So I can use alter table and add column age. And then when we add column age, we have to define the type and the restriction when we add it back. Okay, when we add it back, we add the int as data type and default 25. Okay, so don't forget the semicolon. And when we're gonna highlight it and mix it and execute it, and then you will see that the age is back. But in this case, all right, this is not required, but I give you some extra bonus. So in this case, you can tell that the age is after the active. Since it's after active, because we just add column, so it's following the sequence of the columns, so it adds at the end. But if we want to add this column, right, after the name where the age located before, we can use another way. So let's drop the age at first, and then right here, we want to add the column age after name. Okay, so this after name means we want to add this column age after the name column. So if we execute this, and then we refresh that,
then you can see that the age is back to the location we want it to be. Okay, so this is not required. I'll just give you another tip. All right, and the last one for the auto table is we can modify. Modify is we can change the data type or the constraints of a column. So we can use auto table, modify column name, which is email. So before, the email has the varchar data type with 100 length, 100 characters as the length. Now we want to add more to 150. So we can do is we can modify column email, and we will set the new data type varchar 150, and then unique none. Okay. And by doing this, so right now, if you see the email right here, this is varchar 100, right? This is the data length before. Now we're gonna execute it, this one, and refresh the database list. And now, if you go to here, you will see that the length of the email is going up to 150. Okay, so this is how we're gonna using the auto table to modify the data set, to modify the structure, to modify the data type of a specific column. And the last functionality of the DDL is that we can drop it. Okay, we can drop the table and we can drop the database. So it can delete the database and table. So the drop database will remove the entire database, and then the drop the table will remove the whole table and all of its data. So we can do, let's see, we can drop table, okay, called lead business IS335. And if we executed this one, you will see that the whole table is gone. There's no table anymore, but the database is still right here. And then next step, we're gonna drop the database called lead business. And then if we execute this one, see, the whole database is gone. Okay, so this drop statement is helping us to delete either the table or drop the whole database. So this is the DDL, and since we still need this database and table, so I'm gonna execute it. The first two steps we just did before, I'm gonna execute them, and now refresh. That helped me to get the table and the database and table back. Okay. So this is the data definition language. And after we created the table, so the next step is we have to give some values, right? Add some values, add some record into this table. And that is where data manipulation language, the DML, comes in. And we can use the insert into statement to insert the data into the table. It is possible to write the insert into statement in two ways. The first one is to specify both the column names and the values to be inserted, so that each column corresponds to a specific attribute in the table. Value keywords here is used to specify the actual values to be inserted. And after value keywords, there is a series of the values enclosed into the parentheses, representing a set of the data for each row. It is important to know that each value must be placed in corresponding column position, and the data types must be consistent. For example, we can insert some data into the table we just created. For example, we can insert some data
into the table we just created. So this is the value we can insert into the IS335 table. What we'll do is we will type the insert into the business IS335, and then we will have the bracket for the names. So the names we have, the column names we have include ID, name, age, email, registration date, and active, which is from here, right? And then we will have values. And for the values, for the first row, what we can insert into the first row is this one. Okay, so this is the first row information. We can copy from here and paste into here. Since the name and the email and the date, right, they are all varchar, which are string table type. So we have to use the single quote here to cover the varchar data type or the string data type, right? And then this is how we do. And the other thing I want you to notice about is the difference between the value of a string data type and the column names that we wrote in the MySQL, which is using backstick. Okay, so here is the difference we have. So a single quote is for the string or data value. So you'll use the single quote to represent textual values like the names, emails, or the dates in the SQL. The backtick is for identifier, like the column names or the table names. The backticks are used to surround database object names, like the database name, column names, like especially useful when the names has the space or the name contains some specific special characters. And now let's keep working on this one. We'll copy paste the values into this table. And don't forget to have the comma after each row values, okay? And so that's the second row, and then we'll have the third row right here. Yeah, I forgot the bracket. And you'll see that since we only insert the 3 rows or 3 records into this value, so for the last record, we don't need a comma. And the last thing I want you to notice that true or false here are the values of the active. And the active column is of the Boolean type, indicating that whether a person is active, which is true, or not, which is false. So in this example, the Boolean values true and false are used, and you can adjust them based on your own requirement as like yes or no. And this is the value of the Boolean type. So it's not a varchar or the string type, so you don't need to add the single quote to cover this specific value. Okay, and then we can highlight, oh, don't forget about semicolon. And then we can highlight the values and then click execute. And you will see that this is success, right? And another way is if you are adding values for all the columns of the table, you do not need to specify the column names in the SQL query. However, make sure that the order of the values is in the same order as the columns in a table. So in these examples, the values are provided for each columns in the same order as they appear in the table, including ID, name, age, email, registration date, and active status. So this approach is acceptable when the order of the columns in the values clause matches the order of the columns in a table definition. However, it is generally recommended to explicitly specify the column names when using the insert into statement to avoid any potential issues if the table structure changes in the future. We can also modify the existing data in the table using the update statement with set to change the value, as well as where condition with some conditional restriction. The statement update Lee Business IS335 specifies that we want to update the IS335 table within the Lee Business database. And the set active equals to false sets the value of the active column to the false. So this means that the record will be marked as inactive. And then the where names equals to John Doe condition ensures that the update is only applied to the row where the name column matches the John Doe. So right here, we just insert these values into this table, right? And then we can check about the values that if these values are already in the table. So we can use select all from Lee Business IS335 and to check all the values. So the asterisk here, it actually means select all of the values from this table if there are existing records. I will give you the detail later. Now I just like show you the existing record that we just inserted into this table. So we accused this query. So we can see that this is the information we just insert into the IS335, right? And if we trying to change the active status of the students whose name is John Doe, we can see that the John Doe is the first record, and then the active is 1, which means the active is actually true, right? Because we insert it in as a true. And now I want to change this active and to change it to the false, which is the 0. So what we can do is we can using update statement, update Lee Business IS335 table to do what? To set, okay? So we can set the active, this attribute or the column names equals to false. So this is what we want to change. And who we want to change? We don't want to change everyone. We only want to change when the student's name is John Doe. So we're using where conditions as where name equals to John Doe. Okay, and don't forget about the semicolon. And then we can highlight this statement and click execute. So here we are facing an arrow, right? So this is supposed to be correct, but like something wrong here. So we want to understand what is going on. So we can check the response here at the action output. We can right click this response and then we can copy the response. And after we copy the response, we can actually copy paste here to see what is the error code. All right, so the error code said you're using safe update model and you try to update a table without where that use a key column. So this actually means we are actually trying to update the active status of the students whose name is John Doe. Since there's no key columns in the where conditions, we cannot do it. And the reason is we are in a safe mode, okay? So we have to toggle the option in performance and make the SQL editor and reconnect. So we can do this at first. So the first thing we can do is we can actually go to change the settings. It is in the performance setting and then the SQL editor and go all the way down. We will unclick this one. Okay, and then we click OK. So let's try it again. We need to reconnect. So I will turn this off and open MySQL again. Okay, and then let's run it again to see if it works. Yeah, it works. Okay, so we don't need this arrow anymore. And this is how we can update this. So we disable the save code. And now we can run this select all from the table again to see if anything changed. So now you can see that the active values of the student's names Zhongdou is actually turned to 0, which means it's false, right? And so this is how we're using the update statement to change the specific value in the table. And then, as you can see here, only the active status for the row with the name Zhongdou has been changed to false, and the other rows remain unchanged. Now let's talk about how to retrieve the values from a table. So when there is the data in the table, we can perform various operations on the table through data query language, DQL. It is a subset of the SQL commands used to retrieve data from a database. It's the primary way to extract information from tables and then view the results. So the most common used operation is select from. So the select statement is used to select the data from a table. The syntax of the select statement is like this. Here, the column 1 and then the column 2 are the fields of the name of the table you want to select data from. And the data name represents the table name represents the name of the table you want to select data from. So let's check the example to select data from this table. So this is the table we insert into the database before. So now assume we want to retrieve the names from a table named Lee Business IS335. So we can use this SQL select statement. And so in this query, the select name specify that you want to retrieve the name column from the table. And then from IS335 indicates the table from which you want to retrieve the data. So in this case, which is IS335. So that's the result of this query should be the whole column name, right? From here. Since we only want to retrieve the data name column, so this should be what the result looks like. Let's have a try. So right here, we can see that in the practice, question number 5, we want to write 4 queries to select blah, blah, blah from this table. And then the first query is to select the name. So what we can do is we can using select statement, right? So select name, which is the column name from the business IS335. Let me column, don't forget, and then we highlight this query and we will execute it. Okay, so the result is name and then the 3 records values of the name. This is the column name, and then this is the values of the 3 records, right? So it's success. And now it said another query to select the name and email. So which means we're not just retrieve the one specific column. Well, we want to retrieve the value from multiple columns. So to do so, what we can do is we just need to list the columns from after the select keywords, like this. So if I want to know the names and email of all students, I can write this code, name, comma, email. And then both names and emails are shown, should be like this. So which means I get this column and this column information using the stacked operate, right? And then I got a result showing right here. All right. So let's try it to see if it works. So the next one, I can copy paste this statement so that I don't need to type anything. So here I would just, instead of select name, I will say select name and email from the business IS335, and I execute it. Then I will see that the name column and the email column. Okay. And the asterisk, as I said before, can be used as the wildcard character in the select statement to represent all columns in table. And this is particularly useful when you want to retrieve all available columns without explicitly listing each one. So it is very simplified. It is simplified the syntax, and it's convenient when you need to quickly view the entire content of the table or fetch all available tables. So we actually did this before, right? After we insert all the values into the table, we're trying to using the selector asteroid from the business IS335. So in the future, I will not say select asteroid something. I will just say select all, because this is how we used to talk about, right? The select all from this table. And then this is the all available data that's stored in this table. So here, when it said, oh, you need to select all the information from the IS335, we were using the select asteroid from the table. And the last query, it asks for select the distinct registration date. So the distinct is normally used in this scenario. It's like inside of a table when a column often contains many duplicated values. And sometimes you only want to list the different or the distinct value. Okay. So for example, if you see right here, the registration date, there are 3 registration dates from the 3 records, right? But the values are all the same. So which means these values, they are duplicate. So if we only want to know all the different or all the distinct registration date, in this case, so what we can do? So we can use the select distinct statement. The select distinct statement to return only distinct values. This query will return a list of the unique registration dates from the IS335 table, eliminating any duplicate values from the result set, but not our original table. So right here, we can see that we have like 3 same registration date. So which means they're all duplicated. So there's only one values will be kept in the result of the distinct statement. Okay, so that's just the how we use distinct. And then I can ask you another question. See, if instead of the registration date, what if I want to say the distinct age? Right, so this is the age column, right? So there are 25, 30, 25. And 25 and 25, they are the same value, which means they are duplicated. So that means the result will only be 25, right? And that's the first one. And 30, that's not the same as the first one. So 30 will be kept. And the third one, 25, this is already exist right here. So the result will be, right, like this. And this is the age. So which means the select distinct age will give you 2 records, 2 values, 25 and 30. Let's see if it works in the MySQL. So first one, we will using the select distinct, right? Registration date from the, I'll just copy right here, from the lead business IS335. And let's see the result. Yeah, the result, there's only one value because the registry date has only single value, which is 2023, November 14th. And we'll give you another example to say distinct age, right? So we can try this one, distinct age from IS335 table. And you can see that the result the same, 25 and 30. right? 25 and 30. This is what we just talked about. So this is how you're gonna use distinct to looking for, some different or distinct values from a specific column. And so far, what we talk about is specific on the columns, like how we retrieve the data from the, different columns. And now, what I want to think about is how to retrieve specific values from a table with some conditions. Right, so we can use the where clause to do so. It is used to filter records by extracting only those records that fulfill a specific condition. For example, if you want to know who are less or equals to 25 years old, so let's see in this data set, we want to know who are less than equals 25, right? So this is the age, and we're looking at the age column to find out who is less than 25. So obviously the second records will be eliminated. So it's 30 years old, which is more than 25 years old. So which means the only two records fulfill this where condition. So as a result, I'd firstly filter the age column and select all ones that are under conditions. And then, since this query select the name and age columns from the specific table, the query only retrieve the information like this. All right, so these are the two records from here, and these are the two columns that we selected using this query. See, okay, so we can try here in the MySQL, as I said before, like you want to write a query to return names and age of all records, those who are younger than or at 25 years old. So that means we want to select name and age. So select name, age, okay, from this table. And the condition is those who are younger than or at 25 years old. So which means the age is less equals to 25. And we can have a try execute. And now we can see the result is the same as whatever showing right here. So this is the result of the first record, result of the second record. Okay, and then the age, they're all less than or equals to 25. So this is how we use the where statement to filter the records that fulfill the conditions. Okay. And then we can see right here, less than equal to. So this is the operators. And this is the key things in the where conditions. And we can see those operators that we can use in the where clause. Okay, so this means equal, greater than, less than, greater and than equal, less than equal, and then this means not equal, and this is the between a specific value, light used for specific string pattern, and then in is like to specify multiple possible values for the column. Sometimes we need more conditions than just one. So the where can contain one or more and or all operators right here. So the AND operator is used to filter records based on more than one condition. And these conditions must be satisfied simultaneously. Like if you want to return all students at 25 years old, and at the same time whose active is true. So we can write a query like this. Right, so in this case, there are two students who is 25 years old, and then we check about their active statements, which is true and true, right? So which means both of the records, they fulfill both conditions at the same time. And as a result, it will retrieve the data like this. And we have 4 columns, which is ID, name, age, and active. And so we can write it down here. We will select here. Okay, we select name and age. Okay, so here it only asks for name and age. So select name, age from the business school, where, age. So it said who's are younger than or at 25 years old. So in this case, it should be less equals to 25. And at the same time, the active statement is true. So at the same time, which means we'll have to use and active equals to true. So we can use the select all to check about what might be the result. When we have the select all, so this is the select all information, this is all the information from the table, right? So we're looking at the students who is less than 25 years old, which is this one and this one, correct? And then we're looking at the active is true, but since we updated this active status to false, remember when we did that before? We did this. We update the active status to false right here. So in this case, this record, their status is not true. It's false. So this doesn't fulfill the conditions at the same time, because this one, the age, yes, it's fulfilled, but the active is not fulfilled. So this one will not show in the result. And this one, the age is less than equals 25 years old, the active is 1, which means it's true. So this will be the only result, the record, that's shown in the result. So let's see if I'm correct. So I highlight this query and execute it. So this will be the only records for third students whose age is 25 years old and then active is true. Okay. This is the reason why the results are a little bit different from the slides and the real MySQL, what we just executed. And we can also check write a query to return names and age of our records whose are younger than at 25 years old or whose active status is false. Okay, so we copy paste this execute since it is asking for all, right? So this is not at the same times. So it's not a condition that can be fulfilled at the same times. So that means that it is used to, that means we can filter records based on more than one condition. And any one of the condition is sufficient or fulfilled, then the result will show. Okay, so for example, right here, so this is what we just write, the all. So in this case, when the age is 25, right? So we have 2 records, and then, so which means these 2 records will automatically shown in the result. And then the active is false. So this is the one that, fulfill the sufficient in this condition. And now that means the records number 2 will also shown in the result. So at the same time, either conditions, condition 1, condition 2. So either conditions has been fulfilled, those records will shown into the result. And as a result, we will have all of the records because these 2, okay, they are condition 1. And this one, they are condition 2, right? So this is how we use the or operators in the where conditions. So right here, we can change this one to all and then active to false. And so we can see the result. Yeah, it shows all of the 3 records. And another thing we can do using the DQL is to calculate using some aggregate functions. The most common aggregate functions is count. So which means the count function returns the number of the rows that matches the specific criteria. And so the syntax would be if we use select count and then have a column name after the count. So we will count and then with some conditions, and we will see like how many records are matches the specific criteria. For example, when we have select count all So where the age is 25 years old. So that means we're looking at when the age is 25 and then how many records. So here there are 2 records, right? So it's the 1 and 2. So which means the result will be 2. Okay. So we can write it here like select count asterisk from the business I-35 where age equals to less equals to 25, because here it said those record who are at, okay, this is equals to 25. Okay, and then we execute this one. We have 2, which means there are 2 records whose age is equals 25. But here's a little bit different right here. Okay, so you can see that the name of the columns in the result is still count of the asterisk. However, right here we have the name of the column in the result is student count. So the only difference between the queries showing the slice and the queries right here is there is a S, student count, in the query. So this is what we call SQL alias. The SQL alias are used to give a table or column in a table a temporary name. Alias are often used to make columns names more readable, and an alias only exists for the duration of the query. We're using as keyword to create this alias. So in this case, we have this as like a student account, so it gives it a student account name, and without it, it will only show this one, which is the original result. So what we can do is we can add an alien right here using as student count, and we highlight them, execute it again, and you will see that result change. And the other popular aggregator functions included min and max. So the min function returns the smallest values of the slot of the selected column, and the max function returns the largest value. So here we're looking at the min age and the max age. So we know that the min age is 25 from the records we have in the database, and then the max age is 30. So the result will be like this. Okay, the smallest age and then the largest age. And the sum function and average function also very popular. They returns the total sum or the average value of the numeric columns. So for example, if we want to select the sum age, which is we add them together, right? And then the average age, which is the average value of all the age, and then we can get 85. Which is if we count them all together, it will have the 85, and then the average value will be 27.5. So this is the last 2 question. What is the youngest and oldest age of the students? So we can use select min age, right, as the youngest age, and max age as oldest age from table. As you can see, the result is 25 and 30. And the same thing, we can select it the sum using the sum function to calculate the overall value of age as total age, and average function as the to calculate the average age. And we can also use sum function to calculate the total age. And AVG function, which is the average, to calculate the average age from the table. Right, so this is the total age, and then this is the average age.